Hey guys, how's everything going? This is JSer. Have you ever heard of inversion of control? This is a pretty interesting concept that I learned recently. Though this article is written, I think 2 or 3 years ago. The author is Ken, who is the advocate for Remix. I think this article is pretty cool, and the link is under this video. So if you're interested, you can take a read, and it only costs you, I think, 15 minutes. I will just briefly explain what it is and share some of my thoughts. So yeah, let's just jump straight to the sauce. Inversion of control. So what is inversion of control? If you look at the Wikipedia, it says inversion control is a programming principle inverts the flow of controls as compared to traditional control flow. So it's basically says nothing, right? Let's take a look at the example Ken has put it here. So this is an example. If we want to filter something, we create a filter function, and this is the parameter array. We filter them, and we filter out the empty values like undefined and now. Yeah, basically we just loop through them and check if they are not now and not undefined. We put them into the new array and return it. So it's simple, right? So here's the problem. If we all write code like this without reusing, it's totally fine. But now here's a problem. I want to use this function, but I want more functionality. So yeah, so you can add a second argument saying add another options, filter now or filter undefined or filter 0 or empty string. So these are extra empty values you would think in the future in a later time. So you make this function with this compatibility, and yeah, it works fine. It works as expected. I think it's pretty reasonable to do something in a large code base. There's no time that you can refactor like in a perfect. There's no perfect thing. It's working and it's acceptable. Yeah, why not? So here's the problem. Let's say with this, you cannot. It's not scalable, right? So think like in the future. Okay, what if I want to filter some other values, not 0, but other I would say some values you think it's empty, like 0 empty string. What could be empty? Like I would say not a number is empty. So that's the problem, right? This is not scalable. So how can we do the abstraction of the nice abstraction of filter? So if we took a look at the built-in implementation of array prototype filter, it does something like, okay, accept the first argument as array, and second one is it doesn't say anything specific. It's just a how should I put it? It's a function which you need to provide by yourself. So if you want to filter non-undefined, you filter something like, okay, this condition. If otherwise, you can do something like this, something like this. So the inversion of control means that before, this filter actually has the control of this program, right? It perfectly defines what needs to be done. But now this function does not have this control, right? He passed this control to the argument, to the second argument you need to provide. Yeah, it will listen to the it will see the result of this function and do the filtering. So this filter is more pure than before. Yeah. So this is what the built-in filter does, right? Okay. So okay, this why this is powerful is that it will now support all kinds of filtering you want, but just to provide it, and you can provide like create a separate function to filter this, to pass on to this filter. So what I'm understanding that this inversion of control is nothing magic, but it's kind of like it's a question of how you can do the abstraction better. So filter this It's actually, if you think of the think well enough, you can see that we could actually separate these things into different abstractions. The first is the pure filter, and then the second one is, if you want to reuse, then I can break it down into different condition, like a predictive, I think, something called like that, and you can then combine them together to build more powerful functions. So it's all about how granular what your abstraction is. So it doesn't mean that this is not good. It's totally fine. If it's working then it's fine with enough tests, right? But if you want to make it more scalable, think it more deeper, like how I can make it better. So one example here, I think, I can think of is where it's listed here, compound. Okay, let's just go through the another example and then come back. So there's a called compound component. So if you want to build a value menu, this is, you would think of some API like this, right? Create a menu component, create the button component as a child, and all the items like this. So this is not scalable, because what if you want something not an item menu, like you said? What if there is a separator or something else? So this interface will become more and more complicated when you have more and more use cases. So if you look at this, is that this menu component, what is the true logic that makes it a menu? It's actually, the true logic is the menu will show something when the handle is clicked, right? So when this is clicked, this will be shown. So there's no need to narrow down the types for items. The true logic is the triggering, right? The triggering and toggling. That's why in nowadays, for a component like a menu or reusable component like this, usually I've seen quite some frameworks doing similar things. Like they create a menu component and also a menu button and a menu list. Now in this menu list, you could do anything you want, because the menu only do the triggering. When it is clicked, it will toggle this menu list. So the implementation is quite simple, actually. The menu would be like holding a context, and it will have this internal state of showing or not, and also it will pass down the triggering function through the context. And the menu button will will get the trigger function from the context and trigger it. And the menu list will listen to the flag and conditionally render the list. So this is the true abstraction of menu. You can do this also with render props, but I think this is much more readable. State reducer, I'll skip it. You can take a look. So yeah, this is the inversion of control. One example I think it's better is to illustrate that is, if you want to implement some like a search suggestion, which is type ahead, right? When you type something in Google, it will give you some suggestions. So that kind of component, what is the true abstraction of that kind of component? You can build like everything together if you want to, but if you want to make it reusable, one true logic would be, okay, there are some data source, right? But I don't care about the source, type of the source. It could be any source you want. And the other one is rendering the list, right? Like the menu here. But I don't want to care about what the types of the list is, right? So this type ahead is logic is, when you type something, I will fetch the request and get it rendered. But I don't want to render it directly. You need to provide me with how it should be rendered. That's why for that kind of type ahead, you need to pass down like a renderer, right? How you would re-render each item, and also how would you fetch those data source. So yeah. So my saying here is that my thought on this is that the inversion of control means that you must do the abstraction to the details, to the true form. Like okay, here there are some other examples of inversion of control, which I think it's very enlightening. Like this, inversion of control carries the strong connotations. I don't know what it is. That reusable code and the problem-specific code are developed independently, even though they are operate together in the application. Callbacks, scheduler, event loops, dependency injection, and the template method are examples of design patterns that follow the inversion of control. So for callbacks in JavaScript, we are all used to callbacks, right? When you do something, I will run something, like event handlers, right? Event handlers also. Okay, where are some event handlers? Yeah, I think callback is event handlers. When you trigger something event, you define some logic, say, okay, if some event happens, I will trigger this callback. But that piece of code is independent of how you will do some things. That's the mechanism. That's some framework. Okay, now you need to define those things by yourself separately. Okay, so add event listener to some event and I will do something. So this kind of logic is already is well abstracted by the browser. It will do it for you, this callback. And for example, for event loops, you don't need to worry about it because this kind of logic is done for you. And so scheduler, I've also shared this scheduler internals about React. You can think of the React is also kind of inversion of control. You define something, right? You define something like a render this, render that, but the whole rendering process, you don't do them. You let it, you just define it, but handling the control to the framework. The scheduler will schedule what is important, what is not important, and interruptible or synchronous rendering, all those stuff for you. So you kind of like handling out the control, but the whole system, the whole framework will make sure that you are getting what you want. So yeah, that's it. It's not magic. The inversion of control is just a nice name. The truth is how you do the right abstraction and to make it truly reusable. This part. I think this is very enlightening. Yeah, in the future when I write code, I possibly would think more on this. So yeah, what is the true abstraction? Cool. Sorry, I cost you like 12 minutes, but if you can read it by yourself by 15 minutes or something. Cool, see you next time, bye-bye.